Welcome back to video 3 of the Game Development in JavaScript with P5JS series. And today, not today, I'm recording these all the same day, but you know what I mean. Right now, we're going to make a ball bounce around the screen. That could be really useful in, for instance, a Pong game. So yeah, we're just gonna learn about some basic JavaScript and make a ball bounce around a screen. So hopefully you have saved from last time your code. And let me make sure my timer is running. Okay, cool. You have your code from last time. If you remember, we had hello world showing up. If you don't have that code, then yeah, here it is. Okay. If you don't have that code, then you don't need it. Just copy down this little part of it from right here. Okay. And you don't even need that, to be honest. Yeah, we'll just start from scratch. Okay, cool. I like them being self-contained. So, anyways, make a very basic HTML thing, just like before. And let me make sure my timer is visible. Okay. And now what we're gonna do something different than what we did last time. We're gonna import our JavaScript code, which is the correct way to do it. So we're going to make a file called sketch.js. So yeah, just type this little script line here. We're going to make a file called sketch.js, and that's actually going to contain our JavaScript code. So once again, we'll do like create canvas 500 and function draw background. Maybe this time we'll do green or RGB. Yeah, okay. Okay, so, and then save it as sketch.js. Cool. So now if we run this, we should get just a green screen. So I guess we'll run it. Okay, there's a green screen. Cool. Okay, so now we want to make a ball bounce around the screen. So last time you might remember I very quickly made a ball move around, but now let me talk about this in more detail. So the first major idea is the idea of a variable. So right here, I'm making a variable. Its name is x, and it's starting out as being 0. And I'm going to make another variable called y, and it's going to start out as 0 too. And so these represent the x, y location of the ball that we will draw in the canvas. This thing that I typed up here is a comment. It's not executed as code. It's just here to help me remember it, or to help you remember it. But yeah, these are called variables, and that's how you declare a variable. So now inside draw, we're going to draw an ellipse. That's a fancy way of saying a ball at x, y, and then we're going to pass it the width and the height of the ellipse, which we're going to make our ball 20 by 20. And before that, I can say fill of, let's look up a nice color. Color picker. Let's see, if we look up a nice color picker, a nice color for our ball might be this. So you can use the hex code, but I'll just use RGB, because whatever, I like RGB. And yeah, okay, so yeah, this just stands for red, green, and blue. The amounts of red, green, and blue out of 255 in your color. So now if we run this, there should be a ball in the top left corner. As you can see, there's a ball in the top left corner. Great. Okay. So yeah. Okay, so now we're gonna make it move around. I think to do that, we're gonna rename these variables to be called position x and position y, and then we're going to make some new variables called velocity x and velocity y. And I'm actually going to start out its velocity as 1.5. So vel x is the amount it's going to be moving in the x direction, and vel y is the amount it's going to be moving in the y direction. Like at every frame, we're going to do this. If you've taken calculus, you know that that the position, the way that you velocity is the derivative of position. So to update position, we just want to add on the velocity, or if you've taken physics or whatever. So, okay, so how we're going to do that? We're just going to say pos x plus equals vel x. And we could multiply by some dt. We could, to make it look more like physics, we could say your position, we're going to redefine your position to be what your old position was, plus your velocity, times some increment of time. I'll just make that increment of time 1. Const is different than let. This is declaring a constant variable, a variable that's never going to change. And it's actually conventional to declare constant variables in capitals, but I'm not going to do it here because it's dt. So yeah, okay. Anyways, so we could say pos x equals pos x plus vel x. Okay, and we could say the same thing for y. So these are fairly intuitive physics formulas. Let's see what the motion looks like. It appears to have disappeared. Let's print out. This is a really neat trick. You can go into the developer console by clicking inspect element and then clicking console. And as you can see here, at line 20, we have an error. X is not defined. That's true. I redefined it to be called pos x. So if we change that, then now, hopefully we should see our ball. And as you can see, our ball is moving around, which is pretty nice. Very nice, very nice. Okay, that's very cool. So the next step is probably going to be to make it bounce off the walls. I think that'd be kind of fun. So let's do it. So how should we do that? So the way that you make it bounce off of walls is you have to check if it's hitting a wall, and then if it does hit a wall, you have to like reflect it. This is more physics, I guess. But okay, but let's do it. Okay. So to check if some statement is true, there's this thing called an if statement. It looks like this, and we can basically say if pos x is greater than or equal to width. So this is saying if the x position is really far to that side of the screen. This is like far right of the screen. If the x position is that far, then what we need to do is we need to make it go that way. So we're just going to reflect its x velocity. So we can just say vel x equals negative absolute value of vel x. I think we might actually have to say math.absolute value. But this just means its velocity is going to be negative. So if you hit the right wall, we reflect your velocity like that. So let's see what that does. So we're going to wait for it to hit the right wall. And when it hits it, it hopefully should bounce like that. Is that the right way? Oh, look, there it goes. Okay. That was pretty fun. Cool. So we'll just really quickly add some more if statements, I guess. If the x velocity is, or if the x position is less than 0, then we're at the far left of the screen, and we want to make the velocity positive. Okay, and then we also want to do some more things. I'll just copy these, and let's say if the y position. So one thing you should know is the canvas. If we go to the canvas here, this upper corner is 0, 0, and this lower corner is width height. So if there's this thing called mouse x. Oh, well, okay, yeah. So actually, yeah, that's worth commenting on. So I will make a function. P5 has these really nice things, really nice functions built in. This one checks for mouse presses in the canvas. You can do this with just pure JavaScript, but P5.js has it built in, which is nice. So I'm gonna have this thing say, I'm going to have it print out whenever we click on the canvas, the mouse x. That's the x position of our mouse. So let's see what happens. Let me just delete that. So as you can see, when I click over here, it's 8. And then if I go across the screen, it increases all the way up to 500, which is the size that I declared the screen to be, the canvas. And we could say mouse x comma mouse y. I actually don't know if this is going to work, but okay, yeah, there you go. So you can see both of them now. So like this corner is 500, 500, and this one is 0, 0. If we go over to here, it's 0, 500, And if we go over right here, it's 500, 0. Cool. So yeah, so that's everything that we would expect. Okay, now let's make the ball bounce around a little bit more in the last couple minutes. Once again, we'll copy these. And well, I just copy these for the y. So we're gonna check if the y velocity, if the y position is greater than the height, then we need to make the y velocity negative of what it used to be, or like going up. And then if the y position is less than 0, we need to make the y velocity the positive of what it was. So now, and let me increase the ball's speed, because one way to increase the ball's speed would be to just say that, pretend like there's 10 seconds between frames. So now it's going a lot faster, and as you can see, it's now bouncing off all the walls. And it's not gonna change the pattern that it's bouncing around, I guess. Well, maybe it is. I don't know. It might just be bouncing around in the same pattern all the time. It might be like stuck in a little loop. I wouldn't be terribly surprised. Or maybe it's just like having trouble getting out of the loop. Anyways, but yeah, that's a bouncing ball. The physics is mostly realistic, maybe. Angle of incidence equals angle of reflectance or whatever. So yeah, one thing you might notice if you're looking really closely is that it's not quite right. When it hits the, sorry, I didn't do that justice. Let me make its speed lower again. That'll make it easier to spot. Oh, that's really slow. Okay, well, whatever. Okay, we'll wait for it to hit this wall and we'll zoom in. As you can see, wait, did it work? Okay, never mind. I think it might actually be working. Okay, it's totally working. I don't know what I'm talking about. Okay, balls are drawn from their center, so it is working. Well, actually, no, okay. One thing you could want is you could want it to bounce before the center hits the wall, and then you would just subtract off the radius of the ball. Okay, so I think that's enough for this video. Cool. See ya.